First on the list is exothermic welding. This goes by a lot of names. It can sometimes be called exothermic welding or exothermic bonding, but it's commonly known as thermite welding. Basically, this process involves the exothermic reaction of a thermite composition to heat the metal. It requires no external source of heat or current, since the alumithermic reaction between aluminum powder and a metal oxide creates the heat needed to weld components. One of the companies known to effectively provide exothermic welding services is Rail OK. They are known to be one of the experts in the field of rail-related welding. For years, they've provided welding services to a lot of applications, whether it be the repair of an existing track or the building of a new rail. Their history has proven that they know how to complete welding tasks excellently and on time. They also provide an analysis of what needs to be done to make the whole process more efficient. Rail OK is known for these 4 services: formwork welding, repair welding, glue welding, and thermite welding. This portion will be a focus on thermite welding. Whenever they're tasked to weld railway rails together, one of the techniques they use is thermite welding. It's called thermite welding because it uses a mixture of iron oxide and aluminum powder, which is called a thermite. In this process, they use at least a temperature of 3000 degrees Celsius to begin welding. Here's a step-by-step process of how they do it. Number 1. Preparation. They start by prepping and cleaning the metal parts surfaces by joining. Then, they eliminate any debris, corrosion, or impurities that can compromise the weld's quality. Number 2. Assembling the mold. To keep the molten molds contained throughout the welding process, Rail OK builds a mold around the joint location. The mold often has a riser to let the molten metal flow into the joint and a crucible at the bottom to store the thermite mixture. Number 3. Thermite mixture preparation. Powdered aluminum and a metal oxide, typically iron oxide, rust, are combined into the right quantities to create the thermite mixture. To maintain a consistent composition, these powders are properly blended. Number 4. Ignition. After that, Rail OK puts a sparkler or an igniter wire in the middle of the thermite mixture. To start the exothermic reaction, the igniter wire is lighted. Number 5. Reaction and melting. As the thermite combination burns, a powerful amount of heat is released in a highly exothermic reaction. Over 2500 degrees Celsius is produced by this process, which causes the metals to melt. Number 6. Pouring and solidification. When the thermite reaction is finished, the molten metal pours onto the mold and fills the gap between the metal components. Once this happens, they allow the hot metal to cool normally and wait for it to begin to harden. Number 7. Post-weld inspection and cleaning. If it's done and cooled, they'll start taking the mold off the metal and check the weld junction for quality. They also use grinding or other cleaning techniques to remove any extra material or slag produced during the welding process. Submerged Arc Welding, SAW, is a welding process that utilizes a continuous wire electrode and a flux to create high-quality welds. It's commonly used in heavy fabrication industries for joining thick sections of steel and other materials. Arc Energy Resources has mastered its way to this technique. Ever since they began, Arc Energy has been called to help to provide protection for pipes, valves, flanges, and specialist fabrications used in any hostile environment. They do it through their state-of-the-art welding technology. Arc Energy is known for their weld overlay. This ensures that there is a heavy-duty, metallurgically bonded protective layer that will keep those mentioned materials safe from corrosion. They have a wide range of applications that can benefit from anti-corrosion weld overlay, including pipelines, flanges, valves, vessels, and specialist subsea equipment. One of the many things they're known about is the Submerged Arc Welding, SAW. Interested to learn about it? Keep watching the video! Well, this technique of welding has certain features and components that put it all together. Here are some of them. Number 1. Operation. In SAW, a blanket of granular flux is placed over the welding arc, or is submerged beneath it. The flux has several functions, including shielding the arc, producing a gas for shielding, and forming slag to cover the weld pool as it solidifies. Number 2. Equipment. The major parts of a submerged arc welding setup are a power supply, a welding head or torch, a flux delivery system, and a wire feeding mechanism. To direct the wire electrode into the welding joint, the welding head is normally fitted with a contact tube. Number 3. Flux. An essential part of the saw process is the flux. It's made up of many elements like silica, lime, manganese, oxide, and ferroalloys. The flux composition can be adjusted to satisfy particular needs, such as strengthening mechanical qualities, regulating the weld shape, or increasing weld penetration. Number 4. Wire electrode. Continuously fed wire electrodes are used in submerged arc welding, usually solid. However, it's also possible for the wire to be composite or flux colored. With the wire services as the joint's filler material melts into the weld pool and transmit electric current. Number 5. Advantages. There are various benefits to submerged arc welding. It's appropriate for welding thick sections because it supports high deposition rates. The method has a high rate of efficiency and results in welds of outstanding mechanical quality. Additionally, the submerged arc setup provides good protection against atmospheric contamination. Applications. Industries like shipbuilding, offshore structures, pressure vessel fabrication, pipeline construction, and structural steel fabrication frequently use submerged arc welding. For welding materials like carbon steel, low alloy steel, stainless steel, and some non-ferrous metals, it is especially effective. Number 7. Precautions. Safety measures must be taken when practicing submerged arc welding. The procedure may produce dangerous gases, arc radiation, and high temperatures. To ensure the safety of the welders and bystanders, adequate ventilation, personal protective equipment, PPE, and appropriate training is required. Next on the list is forge welding, also known as fire welding. Did you know that this is actually an ancient yet versatile process of welding? This has also been a standard practice of traditional blacksmiths for centuries already. However, this was slowly replaced by electrical and gas welding methods that can join similar and dissimilar metals, but some manufacturing companies still use forge welding. This technique is a solid-state welding process. It means that two pieces of metal are welded together using heat. This is done through setting a threshold and hammering or pressing the two metals together. Since it uses high levels of heat, the metals become molten, which will later cause plastic deformation on the weld surfaces. Then, the metals are pushed together to create a metallic bond between their atoms. Before, manual hammering was used in this process. Once the metal is heated and it has reached the target temperature, it will be coated in flux. The joint is repeatedly struck by a handheld hammer so the weld surfaces can overlap and join each other. The flux is able to flow out thanks to the hammer blows and the joint's actual creation, which involves beveling or rounded surfaces. To prevent the flux from blasting out of the joint as soon as the initial blow is struck, the hammer blows should only be fairly hard. The development of mechanical hammers further changed the traditional forging process. Originally powered by water wheels, they are now also propelled by electricity, compressed air, gas engines, or steam. Forge welding can also be done with a die, in which the hot metal is placed before the pressure is applied, or with roll welding, in which the heated metals are overlapped before being forced together by high-pressure rollers. Nowadays, forge welding is done in an automated way. Here are the 4 steps of how to do it. Number 1. Preparation. Before everything starts, the forging temperature should be checked to make sure that it is fit for the metals that will be joined. Also make sure that the surfaces are clean. It's essential to remember that these metals should turn yellow when they're heated in the forge, but it should only be done enough to avoid oxidation. Number 2. Flux. After heating the metals, this process will proceed with removing the metals from the forge and sprinkling them with flux. This will protect the metal and stop oxidation from happening, which could cause scales or slag to form on the surface and destroy the weld. Number 3. Heat. Put the metal back into the forge after applying the flux, and heat it up again until it's a bright yellow color. The metal will spark if you keep it in too long, indicating that it has been tainted. Depending on the metal you're using, a different temperature is needed. Number 4. Bringing together. You must remove the metal from the forge as soon as it begins to glow yellow in order to keep it from becoming brittle. The work pieces can now be pressed together to make a weld, or the weld can be formed with a manual or powered hammer. The hammering needs to continue until a clean and finished weld with no weld lines is created. A specific welding procedure known as hyperbaric welding is carried out in a high-pressure setting, typically underwater. It's frequently employed in offshore building and repair projects, like installing underwater cables, fixing ship hulls, and installing oil and gas pipelines. The procedure entails building a sealed chamber around the weld-to-be-done area that is afterwards filled with water or a gas mixture to boost pressure. While also making up for the hydrostatic pressure that the surrounding water exerts, the higher pressure aids in preventing the entry of water and other impurities. Wet welding and dry welding are the two main types of hyperbaric welding. Number 1. Dry welding. With this technique, the welding process is carried out inside a dry habitat, a hyperbaric chamber that is totally sealed. A breathable gas mixture, such as helium or a helium-oxygen mixture, is used by the welder in a controlled environment. The chamber is pressured to correspond to the ambient water pressure, guaranteeing the welder's security and comfort. Compared to wet welding, dry welding delivers superior weld quality and a lower risk of flaws. Number 2. Wet welding. As the name implies, wet welding is carried out directly in water without the use of a dry environment. The welder utilizes an electrode holder and welding apparatus to make for use underwater while donning specialized diving gear. To protect the weld region from the surrounding water, the electrode is covered with the flux substance that emits gases. Wet welding is generally considered less expensive and more flexible than dry welding, but could result in lower weld quality due to the potential water contamination. Both techniques call for qualified welders with in-depth training and expertise operating under pressure. Due to the high-pressure environment's substantial dangers, such as decompression sickness, also known as the bends, and nitrogen narcosis, safety is the utmost significance during hyperbaric welding. With a long history of active involvement in welding research and development extending back to the 1960s, TWI is a leader in the field of solid-phase friction welding and processing technologies. The Institute has solidified its position at the top of its sector thanks to its dedication and innovation and responsiveness to industry needs. Numerous significant inventions and advancements are credited to TWI for its contributions to solid-phase joining processes. Friction stir welding is one such innovation that was quickly adopted by industries due to its efficiency and adaptability. This method, developed by TWI, has completely changed the industry by making it possible to glue materials together in a strong and long-lasting way. TWI has also made substantial contributions to the development of linear friction welding as an established joining method for turbine blades. Through their work, TWI has improved this process, making it a dependable way to create turbine blades of excellent quality. These developments have helped energy generation technology advance. Let us get to know more about this linear friction welding. This is a solid-state joining process pioneered by TWI. This process has been one of the standards of several niche aerospace applications. This welding technique works by pushing together two parts that need to be joined. However, the other one should be oscillating at a low frequency. The friction from this movement is what creates the heat that joins the two parts together. The moment of oscillation that it stops, the parts cool to form a forged quality weld. There are several advantages when using linear friction welding. Here are some of them. Number 1. Consistency. Using this technique, there will be a fast yet consistent process. This ensures that a weld will only take a few moments to be completed. Number 2. Lesser preparation. Using this technique, there will be no need for multiple steps of preparation for the surfaces or parts to be joined. This is due to the fact that the layer of surface metal or flash removes the imperfections and impurities along the way. Number 3. No need for exhaustion. It doesn't need consumables, doesn't emit hazardous gases that need to be exhausted, and because it's a solid-state process, it gets beyond any possible problems with solidification like segregation or porosity. TWI provides a variety of services that can be very helpful to industries and has more than 30 years of experience in linear friction welding. They offer the essential infrastructure for productive and efficient welding operations thanks to 3 potent linear friction welding machines with an axial force of 250 Newton meters. Last but not least, this video has gas pressure welding. Unlike the previous methods, this technique utilizes pressurized gas to create an environment where the metal surfaces can be joined together. The most often used fuel gases for gas pressure welding are acetylene, propane, or natural gas, which are combined with oxygen in the right amounts to produce a flame with a high temperature. The heat required to melt the edges of the metal pieces being connected is produced by the flame created by the fuel gas burning. Getting the metal parts' edges close together and delivering flame to the connection area is how the welding is done. A filler metal rod or wire could be added when the metal edges approach their melting point so that it can fuse with the molten metal and increase the strength of the junction. The use of pressure throughout the welding process is what sets gas pressure welding apart from other welding techniques. Various techniques, such as mechanical apparatus, pressurized gas, or hydraulic systems, are frequently used to apply pressure. The pressure ensures close contact between the molten metal and encourages effective metallurgical bonding, producing a weld that is durable and dependable. Most of the time, this technique is used to join steel frames for building, general fabrication, shipbuilding, construction, and the manufacture of automobiles. Different kinds of metals, such as carbon steel, stainless steel, cast iron, copper alloys, and aluminum, can be joined by gas pressure welding. This technique has its own advantages and disadvantages too. For instance, this technique creates a stronger bond compared to any of the other welding processes. This is all thanks to the pressurized gas that ensures all surfaces are sealed, creating a more secure weld. Moreover, it also does not require high levels of heat. This means that the risk of distorting or warping the material due to the heat is decreased big time. It's also simpler and shorter compared to other techniques. However, it also has its own disadvantages. Here are some of them. Number 1. Control issues. There's a chance that this type of welding is harder to control than the other ones. This is due to the fact that there's no one certain way or visual indicator that can be detected when working with pressurized gases. Number 2. Requires expertise. Since the process involves gases, safety precautions must be properly followed to prevent any hazardous circumstances or mishaps from happening. Gas pressure welding can frequently demand a higher level of competence than other methods of welding, which can take more difficult to locate qualified workers. This is due to the intricacy and the specialized tools needed for its operation. Number 3. Limited to thin materials. One of the issues of this technique is its inability to weld thicker materials. This means that if you need to work with a steel plate, this technique will not be suitable for you. Additionally, not all materials are appropriate for gas pressure welding since not all materials can sustain the high pressures needed for this type of welding. Number 4. Requires high pressure. Although this technique does not require high heat, it requires high levels of pressure instead. Even when it's not that obvious, this factor makes the whole process more dangerous. When doing this, make sure that a special equipment fit for gas pressure welding is used. Number 5. Time consuming. With all things said, it's already imperative that the place or work area needs to be set up first before proceeding to the process so errors are avoided and safety is increased. Due to this, it makes gas pressure welding more time consuming compared to other techniques. Those are just a few of the welding techniques and skills you need to see. If you want to learn more about these amazing machines, you can go ahead and watch our video on powerful and impressively advanced machines with stunning functionality. We'll see you there.